Hi guys. So for this I was about to say for this movie, but for this matrix, um, they asked us to write an algorithm such that. Well, first here's the question. Let me make it bigger. So write an algorithm such that if an element in an n times n matrix is zero, its entire row and column are set to zero. So this is called the zero matrix algorithm. This is from the book How to Crack the Coding Interview. Um, so here's an example. Here's this matrix to the left. Notice we have a zero right here. So if this is zero, this entire row has to be zero, and this entire column has to be zero. There we go. So that's how it'll go. Here, when you have two zeros, this is what happens. So the algorithm of the arrow is time complexity is big O to the n cube. So it's not so inefficient, but if you can find another way to do this, please let me know. I'm going to show you my solution. Hopefully you enjoy it. And if you come up with a different way, let me know again. So first, I'm going to find each element in the matrix. Anytime you have to go into a matrix, you have to go in with multiple for loops. So that's already big O of n squared. So that right there, I really can't think of any other efficient way of doing this. But anyway, let's keep it going. So find the element and mark it. By mark it, I'm going to set it to true or false. It doesn't matter. Just set a mark so you can go back to the matrix. You do not want to do everything at once, as you find out that you run into a lot of errors. So after you've marked them, then you're going to go back into the matrix to find the row and column numbers where you have marked the position that was zero. So this position is zero. I'm going to mark it as true. And then I'm going to go back into the matrix to find where this position is. And there, I'm going to basically make the row zero and make the column zero for this position. So it sounds a little complicated saying it, but it's actually a very easy problem. So here's the test matrix that I'm going to use. Actually, let me use the 413. Let me use the one we have up there. 413, 413, 2 negative 40, 2 negative 40. What's next? 592. All right, beautiful. Okay, so let's start. So let me make this a little smaller. Actually, no, the bigger the better, so you guys can see. So const, I'm gonna call it zero matrix. Zero matrix. I'm using arrow functions here. It's gonna take in a matrix and the size of the matrix. Since it is n by n, it doesn't matter which n we take because they're the same. It's n by n, 3 by 3 in this case. So the first thing is we're gonna mark the positions. So to do that, we need a multiple for loop. So let, instead of var, again ES6, let I equal 0. Well, not I. Let's start with the rows. Let the rows equal 0. Row less than n. Row plus plus. And then once we get one row, then we go into the column. Let the column equal 0. Column plus plus. Column less than n. Column plus plus. Okay, now that we have that, then we simply say if the matrix of row column equals to 0, all we gotta do is set it to true. That's all we gotta do is set this to true. That's it, we're done. We have marked it. So now that we have marked it, all we need to do now is we need to find the locations and zero them. So we need to find these positions that we made true. This place, this row and column number, we need to find it, and then we need to make the rows and column true. So as you can see already, just to do this alone is big O of n squared. That is, the bigger the matrix, the longer this will take for your compiler to finish running. That's basically what that means. But thankfully, this is just a 3 by 3 matrix, so it doesn't really matter. Alright, so next. So we're gonna do it again. I'm just gonna copy and paste this. Saves me a lot of time and error. So now, if erase this. So now we're gonna do a little different. If this equals true, not 0, if it equals true, we're gonna zero the rows, zero the row, and then we're also going to zero the column. Zero the column. Okay, so zero the row, we need to keep the row constants, obviously. So say let I equals 0, I is less than n, I plus plus. So we need to keep the row constants. The row number cannot change in this case, so we can zero the row. If my goal is to zero this row over here, the row is 1 here. So it has to be 1 throughout as you change the columns, right? That makes obvious sense. So to do that, we'll say matrix. We're gonna zero the row while we change the number of column. Beautiful. And we're gonna make that a 0. Then we're gonna do the same thing. We're gonna zero the column now. So to zero the column, we're gonna keep the column constants while we change the row. And that is it, I believe. Now we're gonna return the matrix. Return matrix, and we are done. The algorithm is finished. Let's see what we have. Again, here's the matrix. Here is where we're marking the position, and here is where we are basically filling out zeros. Again, this is a big O of n cubed, because here's one for loop, another for loop inside. Now here is two different for loops, but it's not big O to n fourth because this for loop is not within this for loop. They are additions basically. I'm adding two for loops together, so it's not big O of n to the fourth. It's n to the third power. All right, so let me print this out to show you that it works. We should get something like this back. 410000590. All right, so let's try console.log. Okay, I'm gonna say what's the name of this matrix? It's called underscore matrix. This is called zero matrix. Okay, so zero matrix, passing the matrix underscore matrix, and the number of rows and column is 3. It's n by n. Let's run the test. Let's make this bigger. Okay, hopefully you can see. Oh, get bigger than that, please. Oh, I'm making it smaller. There we go. So node test. Did it work? Yes, it worked. Beautiful. 410. Let's see. Let's compare it to this. Let's compare it to this right here. So 410. Here we go. 410, 410, 000, 590, 590. Beautiful. It worked. So yeah. So you can see this. Our code is pretty simple. Hope you enjoyed it. Thank you.